so let's go ahead now and look at 1.7. And in 1.7, we're going to be combining expressions and simplifying down expressions. So we're not working with equal signs. We're just looking at these expressions, and we're going to talk about how we can condense them down. Now, we do need some new terminology, and we're going to be using the properties from the last section. So the associative property, the commutative property, the distributive property. We're going to be using those, and we're also going to be combining terms together. So let's talk about like and unlike terms first. So like terms have the same variable. Or variables. Because in some cases, they may have more than one variable. (4x cubed and 9x cubed). These are like terms. And they're like terms because they have the same variable. Same power, same everything. However, these would not be like terms. These are unlike terms. Why would those be unlike terms? Because for them to be like terms, for them to go together, they have to have the same variable and the same exponent. These are unlike, they're not like, because they're different. Okay, different variables involved. We don't care about the numbers in front. All we're looking at here is our exponents and the variables. These would be like terms. 8ts and 7ts. These are like terms. These are not like terms. These are unlike terms. So let's look at the difference here. And it's pretty easy to tell if they're like terms or unlike terms. So those are like terms when we look here because the variables and the exponents are the same. These are unlike terms because the variables are the same but the exponents are different. These are like terms because it has both an s and a t in both of them. So these are like terms. And these are unlike because one has a t and one does not. So those would be unlike terms. So are we okay with grouping and talking about like and unlike terms? Now, when we talk about unlike terms and like terms, if they're like terms, they can be combined together. They also have what's called the coefficient, and the coefficient is the number in front. So whenever I say the numerical coefficient, I'm talking about the number in front. So the numerical coefficient of this would be -8. Okay, so -8 is going to be the numerical coefficient of that. If I gave you, let's say, this one, 4x squared y, what would the numerical coefficient be? 4, number in front. So the numerical coefficient is the number in front. when we talk about like or unlike terms, we're seeing if they are exactly the same or not. So coefficient, whenever I say the word coefficient, I'm talking about the number in front. That's just a terminology thing. When we talk about like terms, that means they're the same. So now we're going to be looking at how to use all of our properties with variables, and we're going to be combining together like terms. So, sure.
So if it has like the same variables and everything, if they're like in different order, is it still?
Yep, these are the same. So if I would have gave you, these are like terms as well. How about 8xy and 9yx? These are still like terms. Doesn't matter the order as long as they're both there. Because order is commutative, you can switch the order, it doesn't matter. So those are still like terms. And normally what I do is I just pick one of them and write the other one the same. That way they're the same, they look the same, but they can be combined together. So we're going to be now using these properties to work through some of these, and we're going to be combining together with the like and the unlike terms. So we're going to be simplifying down these expressions. And when I say simplify, what I'm referring to is I'm referring to just combining like terms and using our properties. So let's try to simplify a couple of these down. So we want to simplify this down as far as we can. Okay, yep, we can add the 10 and the 8. Can I put the 9x and the 3y together? No, why not? Because they are unlike terms. So the only thing that I can do on this one, if I gave you this one, the only thing that I can do is I can put the 8 and the 10 together. That is it. That's all I can do. So to answer this question, all I can do is I can rewrite this as 9x minus 3y, and then I can put the 8 and the 10 together, and that's going to make it 18. That's all you can do. Why can I not put anything else together? Why can the 18 not be added with anything else? Because they're all different variables, right? They have to have the same variables to go together. Let's look at another example. Sometimes, though, I've seen students try to add everything together. To combine them, they have to have the same variable. Okay, let's look at this one. Now, when you write your answer, the order doesn't matter as to which variable goes first. Normally I'll write the x first, but you can write the z first. It really doesn't matter as long as they're all there. Now, what can I combine together? Can I put these z's together? No. Why not? Right, this one is z, this one is z what? Squared. But what can go together? Okay, 9x and the 8x can go together. 9 and 8 makes it a 17x there. Then we have a 4z and a minus 7z squared. You can write them in a different order. It doesn't matter. Order does not matter because commutative property says that we can rewrite these in a different order. Now let's go on to another one. And this one we're going to be using our distributive property with. So let's see what we can do with this one. When we work these out, what we need to do is we need to use our parentheses first. So we always have to do the parentheses first. Inside the parentheses, can I add these together? No, they cannot be added together because this is an x and this is a y. But what can I do? Next, I've got the negative 7 out in front. This is where students sometimes make a mistake, and this is why I want you to circle the negative 7. The negative 7 is going to get distributed through. I stop when the parentheses close, so that negative 7 goes through the first 2. It doesn't go through that 2y, because it goes through the 4x, and it goes through to the the positive 3y. The 2y doesn't get it because of the parentheses there. The parentheses tell you to stop the distribution. So let's distribute through, rewrite it, and then see what we've got. So now we have a 9x. We're going to distribute that negative 7 through. Negative 7 times a positive 4. Okay, negative 7 times positive 4, that's a negative 28. We keep the x with it. Negative 7 times a positive 3, that's a minus 21, and it has the y with it. And then we're going to add on 2y at the end. So is everyone all right with how I use the distributive property there? Now we look at it and we see if we can combine like terms together. So let's use our properties to combine these like terms together. What can be combined together? Those x's can go together. I have a 9x and a minus 28x. 9 minus 28. Is that positive or negative for my answer? 9 minus 28 is going to make it a negative. Why? Because 28 is the bigger number, and it's negative. 9 minus 28 makes it a minus 19. And what variable do they have in common? X. So that would give you then a minus 19x. What about the y's? Those can go together, right? What's my sign? Positive or negative for the y components? Negative, and 21 minus 2 is 19, so that's going to be a 19y. Can I go any further? No. Why not? Because the variables are different. Now let's work with some fractions, just so we can review these fractions again. You've seen how to do it with numbers. Now we're going to do a couple of these with the fractions. Same directions. We're going to simplify here. So we're going to start by simplifying these down. Now, with the fractions, we'll just do them over to the side. We need to combine our like terms. So when I say simplify, that means we're using our properties like the distributive property, maybe the commutative property, and we're combining like terms together. So let's go ahead and work with our x's together. Those are the same. They can go together. If we struggle with the fractions like many of us do, we're just going to write them over to the side. So we have 1/9 x minus 2/3 x. Do we need a common denominator now? Yes. Why? Are we multiplying? No. Why are we not multiplying? We don't have any parentheses. So we are adding these together. If we are adding these together, we need a common denominator. What's the least common denominator here? We have 9 and 3. Well, that's going to be easy. That's going to be a 9. So what do we need to multiply that second one by? Well, we need a 9 down below. This one has a 3. So we're going to use a 3 over what? 3 over 3. What does that now leave me with? That leaves me with 1/9 x minus 2 times 3 is a 6. 3 times 3 is a 9x. And now, are they the same? Yes, they can be put together. 1 minus 6, that makes it a minus 5. And what's my common denominator? 9, and we leave our x with it. So that's going to come out to be a minus 5/9 x there. Now let's look at the other fractions. What about the other ones? Well, we can put those together because we have a minus 3/5 and a positive 1/10. We need, again, our common denominators. So since we want our common denominators here, what do we need to have? Least common denominator is going to be a what? 10. So what do I need to multiply the first fraction by? 2/2. That is now going to leave me with a minus 6/10. And then we've got a 1/10. These can go together, and that's going to make me a minus what? Tenths. And what does minus 5/10 reduce down to? You always have to reduce it down. That's going to reduce down to a minus 1/2. So there's your final finished answer. Why can we not go any further? Because this one has an x, this one does not have an x, so they cannot go together. They are different. Let's try another one. I'm going to make one like what you're going to see in your homework. Okay, let's see. How about let's try to see what we can do on this one. There's lots of things we can put together here. I usually will do the variables first. So let's do the y part first. So let's take what we have with y. And we'll put these together. So for the y part, what do we have? We have 8y plus 1/2 y. We can go ahead and put those together as 8 and 1/2 y, right? But normally we won't write it like that. Normally we would convert it to a mixed fraction, or sorry, improper fraction. Right now it's a mixed fraction. But normally we would, this is okay, but normally we would convert it to an improper fraction. And how would we do that? Well, 8 times 2, right, plus 1/2. What does that give you? 8 times 2 is a 16, plus 1 makes it a what? 17/2. And don't forget that's going to have a what on it? Y. I would take the 8.5 y, but normally we would rewrite these as an improper fraction. Okay, we don't use mixed fractions very often. We normally write them as an improper one. Now, that was the hard part. What about the next one? The next ones I made really easy for you. What about the numbers? I have, on just the numbers, I have a minus 1/10. I have a plus 11/10, and a plus 5. Now, I made this one extremely simple because look at what's going to happen with these fractions here. These have the same what already? Denominator. So these can go together. What's minus 1 plus 11? 10, and that's 10/10. Right, plus 5. Now, what do we know about 10/10? 10/10 reduces down to a 1, and now we can combine these together because 1 plus 5 makes it a what? 6. That's going to be our final finished answer. Okay, let's do a couple more of these. I'll just pick one or two of these from our textbook here to look at. using these properties for simplifying these expressions down. Let's do another one that has fractions in it. How about we look at question number 86. And this is on page 93. We're going to look at question 86. So we're going to look at question 86 here. We have a minus 7 fifths out in front. We have a t minus 15. And then we have a minus 1/2 t on the end. So let's take our time. And just because we have that fraction out in front, it's really not going to be any more difficult. What do we always do first? We look inside of our parentheses. Can these go together here? No. So now what do we need to do? Okay, we're going to distribute this fraction through. Whenever it's a negative, I like to circle it. And whenever I use my distributive property, I like to draw arrows so I know where to stop. I stop where the parentheses end. So I stop at that 15. Again, if you struggle with the fractions, write them out. We are multiplying. So the first one is very simple. It's going to be minus 7 fifths t, because there's nothing to do. Those just go together. What about the minus 7 fifths? We're going to have to multiply that by the negative 15. Well, how do I do that? I'm going to write that negative 15 as negative 15 over what? Over 1, right? That's going to make it easier. Now what can we do? Now we can cross cancel, right? Why do we not have to get a common denominator? Are we adding or subtracting these together? No. What are we doing? Multiplying. It's easier. Multiplication is always easier. So now we can cross cancel. So that leaves you with a minus 3 here and a positive 1 there. Minus 7 times minus 3. Is that a positive 21 or a negative 21? Okay, positive. Why? Because a negative times a negative makes it a positive 21. 1 times 1 is 1. We don't need that over 1, so we're just going to write that as a 21. So is everyone okay with how I did this distribution there? The fractions are going to be very simple to work with. There is nothing here, right, on that first one because that fraction just went with the t. Now let's work with our variables because these are like terms and they can go together. So let's see what we've got here. What do we have over here for the t part? For the t part, we have a minus 7 fifths t and a minus 1/2 t. Right? Okay, so what can we do here? Well, what are we going to have? We can't just add these together, right? We're going to have a common denominator, aren't we? So what would the least common denominator of 2 and 5 be? 10. Is everyone okay with that? So we need a 10 because we have a 2 and a 5. So what are we going to have to now multiply the negative 7 fifths by? What gets multiplied by it? To make a 10, 5 times what makes it a 10? 2. So that needs a 2 over 2. And what about the other one? It needs a 5 over what? 5. Now we just multiply. 2 times a negative 7, that makes it a minus 14. 2 times 5 makes it a 10. We'll keep our t. 1 times 5, that makes it a 5. The negative stays there. 2 times 5 makes it a 10 t. Are these fractions the same? Do they have the same denominator? Yes, so they can put them together. Is it going to be a positive or a negative number? Watch. Are we multiplying here? No, what are we doing? Subtracting, right? So we have a minus 14 minus 5 that makes it a minus 19 over 10t. And then we've got our plus 21. I usually write the variable first, but if you wrote the 21 first, that's fine also. But again, watch your signs. These are both negative. If they go together, they make it that minus 19. Because we are not multiplying, are we? If we had parentheses, we would be multiplying, but we don't. That's where students sometimes make mistakes, is they get confused between are we multiplying or are we subtracting them from each other. Let's look at one more. Let's look now at question 90. Then we'll talk about our homework, and we'll talk about our exam next week. So minus 3/4 times 7x plus 9 minus 1/4 times 5x plus 7. When I see an expression like this one and I want to combine them together, what I always must do is parentheses first. And again, if they begin with a negative, I like to circle it. That way I remember to change my signs when I distribute through. So I'm going to distribute that negative 3/4 through, and I'm also going to distribute that negative 1/4 through. And you can write them over to the side if we need to. Take your time with these. We have a minus 3/4 times a 7x, so we'll make that a 7x over 1. Can anything cancel here? No. So we're just going to multiply across. Minus 3 times 7, that makes it a 21. 4 times 1 is a 4, and we'll just put the x on the end. So that one is a 21 over 4x. What about the next piece here? That's 3/4, and we're going to multiply it by a 9 over 1. Nothing cancels, so that means we just multiply across. Negative 3 times a positive 9, that makes it a minus 27 in the numerator in the top half. 4 times 1, that is a 4. So that is now a minus 27 over 4 there. Is everyone okay with how we're doing these? Right, just write them out to the side. If it's a whole number, just put it over 1, and then just multiply. So don't try to make them more difficult. We don't have to have common denominators yet. Why not? We are multiplying. When we use the...
Minus 3 times 7 is 21, but the minus 3 times 9 is minus 27.
Did I make a mistake when I wrote?
You
Oh,
didn't put your
yep.
negative sign.
Sorry about that. You're right. You're right, MJ. Sorry about that. That was my mistake there. I should have been more careful, because a negative times the positive makes it a negative 21 over x. So sorry about that. That was my mistake. Yep. If you see a mistake, be sure and tell me. Sometimes I make mistakes too. I try not to, but they do happen. So, yep, you're correct. That should be a minus 21 over 4x there. Yep, so that takes care of that sign. Same thing on the next one. Minus 1/4. We're going to multiply it by a 5x over 1. Nothing cancels again on my diagonals. Negative times a positive keeps it negative. So that's going to be a minus 5 over 4, and we'll put the x behind. You can keep the x on the top half of the fraction, or you can put it behind, either way. Now we do the last component here. Minus 1/4 times 7 over 1. multiplying negative 1 times a positive 7. That makes it a negative 7. 4 times 1 is a 4. Okay, is everyone okay with that so far? Right? Didn't make any sign error, so if I do, make sure and tell me. What can we now do? Now we can combine the variables together. So those both have an x, so they can be combined together. So what does that look like here? When we combine them together, we have a minus 21 over 4x, and we have a minus 5 over 4x. We are lucky because these already have the same denominator of a 4. And then those can go together. Minus 21 and minus 5. That makes it a minus 26 for 4x. And now we want to reduce it down if we can. So in this case we can, right, because those went together. That gave you minus 26. What about minus 26 over 4? Can that be reduced down? Yes, because these are both even numbers. They both have a 2 in common, so that's going to reduce down to a minus 13 over 2x. Is everyone all right with that so far? Just combine them together. Now, what about the next ones? Those can go together for the numbers, right? These can be combined. We have a minus 27 over 4 and a minus 7 over 4. Minus 27 minus 7, that makes it a minus 34 over 4. And what does 34 over 4 reduce down to? It's not going to come out evenly, right? But they are both even, so divide them by 2. So that's going to make it a minus 17 over 4 there. And that's as far as we can go. How do we know when to stop? Sometimes students struggle with when to stop. Why can we not go any further? These cannot be combined together. Why not? This one has an x. This one does not. These are unlike terms. They're not like, so they cannot be combined together. Now let's go ahead and talk about our homework real quick here. Make sure that we've covered everything. I always like to go over it and make sure everything has been covered. Question 1 is pretty simple. It says, what are some words or phrases that mean multiplication? Well, there's several of them. When we talk about them, what's one common one? When I say multiply, that's the same as saying taking the what? Product, right? There's other words too. You could do times. You could do product. There's some other ones as well, but those are the main ones. Just list one of them out. Just give me some words that mean multiplication. So times, products, those are fine. 2 and 3, all you need to do is combine the like terms. Question 4 is talking about these to see if they're like or unlike, which that's just looking at them. Question 5, we want to know which one has the coefficient of 4. Which one would be the correct answer for 5? It wouldn't be C, because this one's a coefficient of 4 squared, which is 16. So that doesn't work. This one has a coefficient of 1. This one has a 4 down below. The only one that has a coefficient of 4 is going to be what? B. Question 6, we did a very, very similar one. 7 is just, are these like or unlike? 8 and 9, coefficients, so those are pretty easy to do. Question 10, you can work on that one. How would you write that with words? Normally, we take the words and we turn them into mathematical expressions. But in this case, try to figure out how to write this in your own words instead of as an expression. 11, that's just distributing that negative through and then combining like terms. Question 12 is very, very similar to the first one, except we're talking about addition. So many words mean addition. 13, we talked about that one. That's like or unlike terms. 14, okay, what words mean subtraction? Very simple. There's lots of different ones. List some of them out. Okay, 15. 15 is easy, but I want you to understand what I'm talking about when I say numerical coefficient. What would the numerical coefficient of SY be? It wouldn't be 0, okay, because always remember there's a 1 out in front, because this is the same as that, right? Because SY is the same thing as 1SY. So if I put that 1 out in front, now you can see that the coefficient would be what? Would be 1. The 1 is always there, we just don't normally write it. So if there is no number in front, your numerical coefficient is going to be a 1. What about 16? Just to make sure we understand these. Are these like or unlike terms? Like terms, because they're all the same, right? No variables. They can be combined together. Just so we understand what I'm talking about here, those would be like terms. They're the same. 17, you know what the coefficient is. You can find that. 18, you're going to combine them together. 19 is the same. Now, I will tell you kind of what to do on 19, just to get you started on it. I'll do half of it. So for 19, what you would do is you would begin by distributing on the inside first. So 19, you would begin by distributing that 0.02x through. Now the 100 is going to stay there. And when I distribute that 0.02 through, that's 0.02x. And then we have a minus. And 16 times that 0.02, that's a 0.32. And then you can finish it from here. Because once you've done the inside, what are you going to have to do next? Distribute that 100 through. So is everyone okay with what I did on those? Always when you have something that's nested like this, when you have parentheses inside of square brackets, you work on the inside and you work your way out. Question 20. Combine like terms together. After that, what you'll see is you'll see your practice exam. Now, whenever we have a practice exam, I always like to give you a key. Try it on your own first. What you can then do is you can check your answers on the back. I always include the answer key here, so you can just check to see if you're on the right track or not. So you can always look in the back cover, or sorry, the back page of your sheet to check your answer key. I also always make up a copy of how I worked out the questions for your practice exam. This way, it helps you prepare for your exam. And this way, if you're working at home and you work them out, and you make a mistake, you can see where the mistake is. Because sometimes it's frustrating when you're working on things at home and you don't get the right answer. Right? Well, at least now, if you're working on this on Monday night or something, getting ready for your exam, and you don't know how to do one of these and you can't get the right answer, at least now you can go back and you can look at how I worked them out. Now let's talk about our exam next week, so you know what you can have on that exam and how that exam is going to go. So our first exam is next week. And I've got a sign-in sheet I'll pass out too, so I'm going to do that before I forget also. So our first exam is next week. So your first exam is going to be next week. Now, on your exam, what you can have is you can have a page of notes or note cards. So you can have one page of notes. And this can be front or back. Or sorry, front and back. Or you can have note cards. Now, I don't really put a limit on the number of note cards. So if you want to have 6 or 7 note cards, that's fine. You don't want to have too many. If you bring in a stack of like 50, that's probably going to be too many, right? But if you bring, a dozen or so, that's okay too. The note cards I like for you to use because it really makes you go back and look at that practice exam and condense it on to something that you can read. If you try to use a page of notes, sometimes it gets jumbled up. Note cards, I think, are just a better way of helping you learn to study for this class and other courses as well. If you take other classes like anatomy and physiology, note cards really, really help because then you can organize things into smaller chunks, smaller ideas. You'll also need to bring in a calculator. If you forget, I always bring some in to class, but in case you don't, make sure you bring your calculator. I do always bring a few extra, but if you've got one you use, bring your own in. And you can also have scratch paper. Now, how would I study for this exam? Well, the way I would study for this exam is I would go through that practice exam. Your exam is going to be very, very similar to the practice exam. On your exam is going to have 20 questions. So I'm going to cut out 5. Actually, I'll have 22. We'll talk about that in a minute. Your exam will have 22 questions. Oh, thank you. And you're going to be able to skip 2. So on your exam, you're going to have 22 questions on that exam. You're going to be able to skip 2 of them. So those 22 questions are going to come out of the 25 that you have. Different numbers in a different order. I might change a couple of them, but if you can do the practice exam, you'll do fine on your exam. Now, I always like to give you that ability to skip 2 questions because sometimes students get stuck on one particular question and they can do everything else, and that's really frustrating and it ruins your whole exam. So by allowing you to skip 2 questions, if you come up to a question that you just really don't know how to do, you can skip that one. And it helps you maintain that focus and finish your exam. So that's why I always try to add in 2 extra questions or 3 on your exam, and you can skip a couple of them. That way it keeps you focused. A lot of this is just getting over some of the testing anxiety and just letting you skip a couple of questions. I think that really helps get rid of some of that fear of exams. So that's why I do that. So that's what's going to be happening next week. We're going to come in. We're going to review for our exam first. So any questions that you might have, we're going to go over those. On exam days, I don't ever cover new material. I know we have a 3-hour block. Normally on exam days, we get out early because I really can't cover new material. Because if I try to give you new material at the beginning, you'll get confused before you take your exam. If I give you new material at the end, then some of you might try to hurry up and rush through things because everyone else is finished and waiting around. So on exam days, normally what we do is we go over our questions from our homework. We review for our exam a bit, and then whatever time is left over, you have plenty of time for your exam. Also, don't forget your homework is due next week. So what's due next week is that homework packet. That whole packet. So make sure you bring that in. So you'll want to make sure you have that packet for next week. You should be able to finish it all, and we'll have our first exam.
Can you just show like how we did the work with that?
Yeah, on some of them you may. On some of them you may not. Like some of these questions on especially identify the property, you could just write the property down. But if you have extra work, attach it at the end with a stapler. So I always bring a stapler and you can attach your work at the end. And I do look at that, and sometimes people make a mistake because they might write down the wrong answer on the front, but I'll find it in the work and you just wrote it down wrong. So I'll give you credit for that. So if you have work, you can attach it at the end. But some questions don't require it. So I will see everyone then next week.